It's such a beautiful day for a bike ride. Maybe I should ask my friends Blake and Hailey if they want to come with me. Hey guys.
Hey.
Hey,
You guys want to go on a bike ride with me?
Sorry, we can't. We have a calculus test.
it's on average velocity.
Oh, well you guys can take the average velocity of my bike ride.
Really?
Yeah,
What's your path gonna look like?
it's gonna look like this.
Hey, that kind of looks like a function.
We can turn that into a sine function.
And then we can find the average velocity and total distance.
Okay, let's go. Because of the calculus skills that Mr. Reyes has taught her, Irene knows that her bike ride actually involves calculus. This is where the problem comes in. If Irene's displacement is represented by d of t equals t cosine t plus sine t with d of t in miles and t in minutes, we can use this information to find her average velocity.
First, we should graph the function. Find the maximum, minimum, and zeros of the function between 0 and 20 minutes on your calculator and graph it on the x and y axis. This represents Irene's displacement on the first 20 minutes of her ride.
Next, we need to find the velocity equation. This can be done by determining the derivative of the displacement function, which is given in miles. In order to find the derivative of d of t equals t cosine t plus sine t, you must use the product rule on t cosine t because it is a product of two functions. If you don't remember the product rule, it is the derivative of u times v is v times the derivative of u plus u times the derivative of v. In this case, if t is u and cosine t is v, then the derivative will be d prime of t equals cosine t minus t sine t plus cosine t, or d prime of t equals 2 cosine t minus t sine t.
The next equation is the total distance Irene traveled from 0 to 20 minutes. We know that distance is equivalent to the absolute value of the displacement over the interval, so in order to find the displacement from 0 to 20, we must integrate the absolute value of the velocity equation bounded from 0 to 20 minutes. This can be done using numerical integration on your calculator.
For all those tryhards out there, you know who you are. You can also do this problem without the use of your calculator's ability to numerically integrate. This would be done by first finding the subintervals where the velocity function is positive or negative. So in order to find this, we must use the zeros of the velocity equation, which are the max and mins of the displacement function. In this case, these are located at t equals 1.077, 3.644, 6.578, 9.630, 12.722, 15.834, and 18.955. Now we can determine the subintervals using our superior calculus knowledge. We know that by looking at the graph of the displacement, the areas where d of t is increasing is positive, and the areas where d of t is decreasing is negative. In this case, the subintervals where the velocity is positive is from 0 to 1.077, 3.644 to 6.578, 9.630 to 12.722, and 15.834 to 18.955. The velocity is negative along the subintervals of 1.077 to 3.644, 6.578 to 9.630, 12.722 to 15.834, and 18.955 to 20. Now all we need to do is a ton of integrals and add them together. However, for each of these integrals with the subintervals that are negative, we must take the absolute value. So it would be the integral from 0 to 1.077 plus the absolute value of the integral from 1.077 to 3.644, and so on. This should get those tryhards to the same solution as us regular people.
The final question that Irene wants to know is her average velocity over the course of her bike ride. In order to find this, you take the integral of the velocity over the boundary of t equals 0 to 20 minutes. Using the average velocity equation, we can plug in the boundaries of the integral and the velocity function. By solving the integral of the velocity equation, which for simplicity reasons can be simplified to d of 20 minus d of 0, since this represents the rate of change of the displacement, aka the velocity. By dividing the value of d of 20 minus d of 0 by the value of 20 minus 0, which is 20, we can get the average velocity in miles per minute. This can be converted to miles per hour using the dimensional analysis where 60 minutes equals 1 hour. Thus, Irene's average velocity is 0.454 miles per minute, which equals 27.224 miles per hour.